3, delete tree nodes. So for this problem, we are giving a tree rooted at not 0. So we have the following conditions. So this is the root. It's going to be starting from the node 0. So the number of nodes is this node. So for example, nodes equal to 7. It means the number of the nodes is 7. And it's going to be a tree structure because we're going to have a root node of the tree. Yeah. So the value of the ith node is value I. So for example, the value 0. So this means the node 0 has a value of 1, and the value 1, so the index 1, it means yes. So for node 1 has a value of minus 2, negative 2. Yeah. So the parent of the ith node is parent I. So for example, yeah, for the 0th node, because there's no parent, so it's going to be a negative 1. But for the node 1, node 1's parent is 0, and node 2's parent is 0. Yeah. So this means just the parent. So for node 3, its parent is 1, and similarly for 4, 5, 6, its parent is 2. Yeah. So remove every subtree whose sum of the values of node is 0. So for example, the subtree 2, 4, 5, 6, because 4 plus minus 2 plus minus 1 plus minus 1 is 0. So we're going to remove this subtree. And for this node 3, because the value is 0, so we're going to remove this node 3. It's going to be a subtree itself. So what's left behind is this node 1 and this node 0 and this node 1. And we're going to return the number of remaining nodes in the tree. So for this example, we're going to have only 2 nodes. So this is why we just return a number 2. And similarly for the next example. Yeah. So according to this kind of a tree structure, and according to the condition, the sum of the nodes value of the subtree, if it is equal to 0, so we're going to remove it. So it seems that this problem can be solved by topological sort. So it is a topological structure for the tree itself. And if we can find the conditions like this node 2, 4, 5, 6, the value, all of them sum up equal to 0, this means we're going to remove it. Yeah, but at the same time, we need to count the number of the nodes. So for example, the number of the nodes, we need to set an array, the number of the nodes. So for example, at node 0, we're going to set a number of the node going to equal to 1, and for all other places, we need to set the number of nodes. So this is a similar like dynamic programming. Yeah. So from the beginning, we're going to set the number of nodes at each node, so we're going to set it as 1. But at this condition, this is 1, 1, 1, and here is 1. This means the number of nodes from this node 2 is going to be 4, because including the self and its subtrees, so the total number of nodes at this node 2 going to be 4. Yeah, but the value is like 4 minus 2 minus 1 minus 1. The value is 0. So if the value is of 0, so we're going to set the number of nodes at this node 2. We're going to set it to be on 0. And similarly for here, so the number of nodes from beginning it is 1, but the value is 0, so we're going to set it as 0. And similarly for here, the number of nodes is 1, 1 plus 0, this is 1. And here, because this is 0, this is 1, and this is 1, so the number of nodes at this node 0, it is 1 plus 1 plus 0, so it is 2. So finally, we just need to return the number of nodes at this node 0, so which is 2. Yeah. Now let's just start programming. Yeah, even though this is a tree structure, but we just need to turn the directions, and we're gonna use the topological sort. So we're gonna use the integrate for this node 2, it is 3. So integrate for this 4, 5, 6, it's gonna be 0. Yeah, so this means we're gonna turn all the directions. But actually, we don't need to turn it. We just in programming, we just need to use the integrate. Yeah, actually we turn the direction, and we're gonna solve it from bottom up until we find this node 0. We're gonna return it. Yeah, because for topological sort, we're gonna set the integrate, and we're gonna use the node if the integrate is 0. But actually, as we can see, the integrate for 4, 5, 6, it is 1, but actually it is not, because we're gonna turn the direction. So after turning the direction, the integrate for this node 4, 5, 6, it's gonna be 0, and also for this node 3, the integrate gonna be 0. Yeah. Yeah. It is in our programming, we needed to use this integrate to solve the problem. according to the topological sort idea. But actually, we don't need to turn the directions. We just need to use this kind of idea to solve it. Yeah, even though the direction is like 2 to 4, but it is okay. We just use the integral of 2. It means the integral of 2 is gonna be 3 instead of 1. Yeah, because we're gonna turn the directions. Yeah. Now let's just start programming. So let's just prepare the integral first, because we're gonna use the topological sort. Yeah. So we're gonna use 0 times the number of the nodes. Yeah. Now we're gonna check the parent. So for parent inside the parent, so if this parent is not equal to -1, so this means it's gonna have a valid parent, and we're gonna set the integral. Yeah. So integral for this parent. So for example, the integral parent gonna plus equal to 1. Yeah, this means for the first one it is -1, we will ignore it. But for the second one, the integral of 0, it's gonna plus 1 and it's gonna plus 1. This means the integral of 0 gonna be 2. Integral of this node 2 gonna be on 3. Yeah. So let me just print out the integral to check what is that, and let me just return a 0 at the moment. So we can see inside the integral array. So this is the integral for the first example. So for this node 0, the integral is 2. For node 1, the integral is 1. For this node 2, the integral is 3. And for 3, 4, 5, 6, the integral is 0. This is exactly what we need, because in our topological sort, we need to put all those nodes 0, 0 inside the queue. Yeah. Now we're going to prepare a queue. It's going to be a double-added queue, and we're going to use the I. It means the node. For ID, D means integral. Enumerate the integral. So if the degree, D just means the degree. If degree equal to 0. Yeah. So now we have the queue, and we're going to use the BFS topological sort to solve it. But before that, let's just use another array. We're going to call it number of nodes. Yeah, so this is exactly what we need. So from the beginning, we're going to set it as 1 times the number of nodes. Yeah, because we use this dynamic array. Yeah, this is the dynamic programming idea. So we're going to use this 1D array to get the final solution. Yeah, because the final solution going to be the number of nodes 0. For the number of nodes 0 means how many nodes for this node 0. Yeah, which meet the conditions from the question. Yeah, the number of remaining nodes in the tree. Yeah, so for example, at node 0 it is 2. So this means the remaining nodes. Yeah, at each of the node, if that is possible. But for this node 2, it is 0, because this is going to be removed. So the number of nodes at node 2 is going to become 0. So this is the definition of the number of nodes. So it means the number of remaining nodes starting from the current node, this node. Now let's just start the BFS. So while Q, we're going to pop out current node. It's going to be equal to Q dot pop left. Yeah, and we need to have a check if the value, because we have the value. If the value of this node equal to 0, we're going to set the number of nodes at this node. We're going to set it to 0. Yeah, because we're going to at the same time, we're going to use this 1D array, and we're going to calculate the value. So for example, the value at this node 2 is going to become 0. So this means the number of nodes at this node 2 is going to become 0 as well. Yeah. Now we need to find the parent. So the parent is going to be the parent array with this node. Yeah. And we can calculate the value and the number of nodes. Yeah. So the value of the parent gonna plus equal to the value of the current node, and the number of nodes at this parent gonna plus equal to the number of nodes at this node. Yeah, so we just need to sum up the value and the number of nodes, yeah, at the same time. we're gonna just use the value array and the number of nodes array at the same time. Yeah. Now what about the integrate? So the integrate for this parent gonna minus equal to 1. This is exactly what we are doing for the topological sort. Yeah, because after using this node, for example, this is node 4. The integrate of 2 is 3. So after using this node 4, so the integrate gonna be reduced by 1. It's gonna become 2. Yeah. Until this integrate is 0, we're gonna put it inside of the queue. So from here, we need to have a tag. If the integrate of this parent equal to 0, so we're gonna put it inside of the queue. Yeah, we're gonna put the parent inside of the queue. Yeah. So this is all about it. Yeah, let me put it like this. Yeah, and let me just submit it to tag. As you can see, it works. Now let me just submit it to tag if it can pass. As you can see, it passed for all testing cases, and it's pretty fast. Yeah. So the idea is just the topological sort. Because the direction is just like a tree structure, actually, while we are calculating, we need to turn the directions like 4 to 2. But actually in programming, we don't need to do it. We can just programming, and we can just imagine the direction has been turned. Yeah, the direction is reversed. Like from 2 to 4, actually it is 4 to 2. Because after reverse, definitely we're gonna use the topological sort. Yeah. I think that's all about it. And thanks for watching. See you next time.